Okay, can you guys hear me? Okay, can you guys hear me? Okay, let's get going. So, as the description says, today we're going to be looking at translating Rob Pike's Ivy, an APL-like calculator, into Rust. Now, before we do that, I think it probably makes sense just to do a little demo of Ivy. So, as I mentioned in the description, what really inspired me to do this was watching Russ Cox use Ivy, solving these Advent of Code puzzles from last year. And I think I got linked to this from Hacker News, actually. Let's see. Day 1 using Ivy. Yeah, this is really, really cool. So, I've had kind of a long-standing interest in APL. I tried learning... well, of course, I was reading the dialogue book, but I didn't want... It seemed kind of hard to use dialogue on Linux, if I remember correctly. And then I tried using J for a while, and I just had a hard time. Usually when I wanted to use one of these languages, it was doing like data analysis on stuff for a paper, some kind of chemical data I had, and I always had a hard time getting the data into them. I also tried using GNU APL and had some trouble with that as well. So anyway, I have an interest in APL. Of course, I've always wanted to write my own language. This doesn't really qualify as that because we're going to be copying this existing code, but I thought it would be kind of fun to translate it into Rust. And at the end of it, we should have a nice little, something that's like APL, that hopefully I can actually use for my data analysis. And if I can't use it, I should have the groundwork to change it away from the Go version to make it more useful for me. So it seems like a fun thing to do. But first things first, we're going to try out Rob Pike's version. And I think, yeah, we can run the demo. So obviously I've been seeing what this looks like, but just to give you all a flavor for it, let's zoom in a bit. We'll do this. So this is the demo. We can quit each step. Okay, great. So this is simple, doing math, of course. Yep, we got comments. Whenever you like, type an expression yourself, followed by 2 new lines. Okay, here we go. Here's the demo. Arithmetic works. That's great. Cool. 2345 times 45 minus 45 to the power. Can we clear? No. 7 mod 3. Yes, operator precedence is unusual unless you're familiar with APL. Yeah, everything associates to the right. Yeah, so this is 3 plus 4 first, then times 2. Yep. Okay, so this is all the basic stuff. And of course, one of the interesting things about Ivy is that it does this rational arithmetic. Because if you watch, I also watched this talk, and kind of the impetus, I guess, for building Ivy was doing cryptographic calculations, I think. So using large integers, where you want exact numbers like this. So for me, I'm actually going to want floats if I'm going to be doing data analysis with this. So that may be one place where we start to diverge. But from what I read on here, it does support floats, actually. So hopefully we'll see that in the tutorial. Okay. This is cool. I mean, rationals are cool. Non-integral. Okay. Yep. Perfect. Yeah, Ivy is a big num calculator that can handle huge numbers and rationals of huge numbers. So we got still an integer. Really big. That's cool. I mean, that's really cool. Complex numbers. Great. Square root minus 1. So, I mean, here's a float, of course. We have characters. Oh, man. Russ Cox did something really cool in one of the videos where the Advent of Code, it was supposed to you had like a grid, and then it was supposed to represent letters, and he did like a string replacement on like a matrix of ones and zeros, and he replaced it with like a dark square, so it actually made a grid. Really cool. Okay, yeah, okay. There's I guess that's a poop emoji. We can actually look at the demo over here too. I'll see the emoji. Oh, there it is. Yeah, yeah, of course. Okay, you can put stuff in a vector. Great. Yep, you can just put them together. Arithmetic works. Very cool. Very cool. So anyway, I mean, we're just now getting to some of the keywords. We've got like iota, probably there's row, take, drop, stuff like that. But that probably gives enough of a flavor for it for now before we just jump into the translation. So let's go ahead and do that. I guess we'll quit the demo. I'll go into my projects directory, cargo new, algae. So it maybe it's kind of a dumb name. I just thought like algae is kind of like the ivy of water, and then there's also, if you actually Google like rust algae, they're like these brown algae colors or orange algae. So I don't know. I thought it was kind of rust-like. Whatever. It's a little sad because ivy is actually named for. Why is it showing? Yeah, is actually Ivy, like Ken Iverson, who created APL. I tried thinking of something with another part of his name. Oh, look, this has like a G in it at least. Algae. Oh, we could have called it Algene. That's probably too close to Nalgene. We're going to get sued. But anyway, I like the name Algae. It's fun. Cool. So we got the project. Let's open it in Emacs. Algae source. librs. Please import my thing. Okay. So I better bring this over here, actually. I'm going to have to... Yeah, I'll have to check back in periodically over here because I can't... I only have one monitor right now. And let's just get going. So we'll go over here to the code. Alright, thank you. Let's see, we'll go in here. So, I mean, this is great. We're basically just going to be able to copy the structure, I think, even. So we'll have these modules, config, exec, parse, run, scan, value. We have a context. Scan new. Now the question is just where to start. Scan new. Name string. Yeah, it looks like this is probably where we're going to start. Config. What is conf? Oh, config.config. We might be able to skip that for now. I kind of want to get straight into the exec. Oh my, context. All right. Well, anyway, I guess we'll start from the top then. And I guess one other thing to say is that I've probably said this before on the channel, but Go was like the first language I learned, and it's what I wrote all of my research code in for the first like year or two that I was writing research code. So hopefully this is going to go well. Hopefully I know I will be able to follow what's going on very well. Much better than when I was looking at libint, for example, where I have no C++ experience. Okay, so we're going to skip this for now, the flags. Later on we'll add clap for that. Okay, we're going to skip the CPU profile, obviously. If star origin. Set index origin. Oh, that's pretty cool. Okay, but defaults to 1. We'll stick with that. Stick with that. Okay, so we've got this global config. So these are slightly frightening because they're globals. So we're going to have to decide, are we going to leave them as globals, in which case we'll have to probably put them in a mutex or a reader-writer lock, or are we going to pass them around everywhere? And probably I don't really want to pass them around everywhere, but we'll see. Alright, I guess we'll just start with the config, and then we'll do context. And then we will go scan parse. Config. Wait, where's context? Value.context. Okay, so config, value, scan, parse. I'm sure we'll find exec at some point. Where does exec actually get used? Okay, it looks like exec isn't used in here. It must be, right? Oh, there it is. Exec new context. Alright. So again, we'll start with the config. So mod config. We'll do it like this. We'll move it to a file later. Mod config. And we'll just jump in. I don't know why sometimes GitHub will let me jump to things and then sometimes it doesn't. You know. Okay, well, anyway, we'll jump to config, config.go. Order here determines order, and then config. Oh my goodness. Well, we'll start with this, direct config, go to prompt, string, output. Okay, I guess this is going to be generic. Oh, whoops. Output, air output, also a writer. Oh, this is not, yeah, whoops. I kind of want to call this like stand out, stand air, but I guess we'll stick with this for now. Format, rat, format. I guess this is, yeah, formats. This is the format for rationals. Verb, a byte. I think that's a char for us. Or char if you prefer to say it like that. Format precision. Int. I think we can just use a usize. Format float. Bool. Origin usize. Big origin is a big int. I'm not really that interested in doing big ints. At the same time, I kind of hate to diverge from the code immediately. Let's see. Yeah, we probably have to get a crate. All right, we're gonna skip big ints for now. Origin, big origin, seed, U64. That will probably change later. I'm guessing it's actually int64. Maybe it's supposed to be I64. Yeah, this will probably change at some point. It'll just be whatever our random stuff takes. I'm assuming this is a random seed. Debug. we'll probably skip that for now. Oh, and then these are rand source, rand. Okay, we're gonna skip the random stuff for now. Because I know we're gonna have to use like the rand crate. Rand nursery, yep. I've used rand like once before, so yeah, we'll have to see. Okay. Skipping the rand stuff for now. Max bits, and we'll probably, yeah, I mean, we'll skip this stuff for now, maybe. Well, alright, we'll just throw it in here. I guess it's easier to delete later. Max digits, max stack, float. I thought we already had this. Oh, format precision now, float precision. Yeah, I mean, I've even thought about doing all of the numbers in just as floats. You know, since I'm interested in using this for like data analysis, I'm not really that interested in the integer stuff. But again, might be easier to do that later. I guess we'll do this as well. So this is a time. This is probably like a system time. Input base. Output base. And we're not going to support mobile platforms, so we can definitely skip mobile. Okay, I guess we should take the verb if format is floating point. Yeah, and then these should be like verb. That's not what they call it in Rust. Okay. This is the init, so I think this is going to be, this is our default. Whoops. Oh, duh. Alright, prompt. Well, the default prompt is nothing. Output is, oh boy. Let's see if this is going to work. We might have to change our trait bounds. Yeah. We're going to do, we'll have O and E. Because we don't want to require them both to be the same, obviously. Why is it mad about this? Oh. Format. Apparently nothing. Rat format, also nothing. Format verb. Format precision. Format float. What is this supposed to be? Oh. What? Oh. So maybe, does that have to be an option? How do you make an empty char? I guess it has to be an option, actually. Oh, I guess we could use the... Yeah, I don't want to use null. Okay, format verb. Will my language server do it? Option? No. And okay, format verb. What is that supposed to be? Format verb The verb if format is floating point. It would be nice to see format verb is 0. So I think this is where I think we probably don't even have format verb, right? Because for a float, for example, yeah, so in Go, I think this would be either like F or E or G. But in Rust, we don't use F. But we could use E. Okay, I'm just going to make this a string, I guess. Because it can be empty, format verb. String new. Format precision. We will set to 0. 0. Oh. False. The origin is 1. Seed. I do kind of want the random stuff. It's kind of cool. API reference. Quick start. Okay. So use random. Alternatively, you can use thread RNG. I don't want to read the Rust Rand book. Alright. This is probably impossible to read, right? If random. Okay, we need a random seed. Where do you get a seed? Fixed seed. Okay, time.now.unix nano. Oh, I've done this before. How do I get the time since? Actually, wait a minute. Go time Unix nano. Let's see, Rust, Unix time. Unix epic. Yeah. Okay, there we go. And is it, you can't get this in the regular time, right? Time constant. Oh, you can. Okay, we'll just use this then. Oh, it is a system time. Okay. This will be system time before the Unix epic. I mean, that's insane. System time now dot duration, not now duration since Unix epic dot unwrap dot as nanos. Yeah, and it's a U128. And 64. I wonder if we're gonna have to cast this. Where did my, wait, what? From seed. Here we go. Takes a seed. Oh god, it takes a slice of U8. How do I get a new seed? I don't want to implement it. Does it not come with any seeds? Oh, from RNG. A new PRNG seeded from another RNG. From entropy. Seed type restricted to types mutually dereferenceable. Okay, so this is probably just not even how, this is probably not even how this crate works. I would like to seed it. Random. Let's see. Rust seed RNG. The seed type. We require all seedable RNGs to define a seed type satisfying this. U812. Let's see. So if we have a U128, rand core, a simple number. Here we go. Okay, well we can do this then. So let's do cargo add rand. We might need some features here, but we'll see. Great. Okay. We'll just make this a U128. Now, what I do want to do is I'd like to just make sure seedable, seed from, oh, it only has U64. I wish I could do a U128, but we'll see. Maybe we can convert it as nanos. We'll try to cast it to a U64. Well, we could just use as what? Oh, they all do U28 as seconds. Okay, that'll give me a U64, which I can put into this. Okay, U64. Now we can go back over here. Max bits, 186. I don't think it'll let me do that. Yeah. 1,000,000. Wait, what? Oh, whoops. Max bits, 1E6. Oh, you can. Okay. Max digits, 1E4. Max stack, 1E5. Float precision, 256. Real time, of course, is none. Duration, default. Input base, I guess it's 0. Yeah, 0 means C-like. Base 10. Yep, 0. And output base, also 0. Oop. Oh, did I leave this up here? Now I forgot what it was supposed to be. View size. Okay. So that's our config built, and it gives us default. These are just helper methods, it looks like. Set format. Okay, let's go back over here. iv.go. Conf set format to format. I guess let's go to main. Whoa. Oh, duh. Obstruct. So what I'm just writing a note for later. So instead of doing this, where we like set it one at a time, we'll probably just make a config new function that takes as arguments all the stuff that we actually want to set, and it'll fill the rest with the default. So we'll start with that. Okay, I think that's all we need from config for now. Duplicate. Looks like the next thing we're going to do is a context. Which is an exec. Okay. Context exec.new context. So we'll make another module. Oh, it doesn't like that actually, does it? That should work. Of course, these are unused. Maybe they should be pub. We'll see. Or we should make a bunch of getters, one way or the other. Okay, so new context. We have another config. I think we're gonna have a mod. I guess we'll just follow this, mod exec, and inside of exec, I guess we will have another module called context. This should be pub, I think these should both be pub. Pub mod context, struct context. It's gonna have a config, but it's gonna have a pointer to a config. Okay. Conf. Oh boy. Okay. Well, I certainly hope that we're not going to be mutating that. This is going to be a disaster. Alright, so this is going to be generic. We're going to specify the lifetime. It's going to hold a config, which is a reference. Tick a to a config. What? Oh, this has generics. Let's just deal. We'll just go with this for now. Ah, no, we better do it right, huh? I don't have any restrictions on this yet. Yeah, I guess this is the way to do it, huh? The trait bound O is not satisfied, of course. Okay, there we go. Great, those are the bounds on our config. Oh yeah, so I forgot to mention this before, but yesterday I actually cloned the Ivy repository and checked how many lines it contained. And it's like 11,000 without comments. But what I'm hoping is that it was written before Go had generics. So I'm hoping that we can use generics. Not really like this, more like when we get toward like the actual numeric operations. I'm hoping that we'll be able to use generics to really shrink that code size. Because just browsing through the repository, I saw that there was quite a bit of code duplication. I think. Maybe it's not duplicated, and we'll see that as well. Okay, so we've got a config. Value context config method. Frame sizes is a vec of int. Frame sizes vec. We'll start with usize. And stack is a vec of value, which we're going to have to find. Okay, this is a value.value. So we have another module. Value. We don't know what it's going to contain, but for now we can just do this. This is horrifying, another global symbol table. I guess that actually makes sense though. Oh, I've done this before, globals. Oh no, this is just a type. Whoops. Oh, okay, no. It's in the context. Makes sense. So this is a type alias. Okay. So this one's supposed to be pub, I guess. Yeah, I mean, I was thinking, oh, maybe we should add documentation comments. But I think global's symtab is pretty clear. Global symbol table, which is as much as I know about it right now. Unary fn. Oh, okay. Neat. String to function. Oh boy, what's function? Exec function. Okay, so we've got unary function table. Okay, which is the hash map of string. These might be like, I guess they do have to be strings. They can't be like static strs or anything. String to a function pointer. We'll just say it's to a function for now. Binary fn similar string function. These might have to have like different types. We'll see. Defs is a list of defined ops in time order. Yeah, I think it will look like that actually. Opdef variables is a vec of string. Shouldn't names of variables declared. Oh, okay. So this currently being parsed function. So I think this is just like a buffer basically. Okay. Anyway, function. Yeah, I know you can't find it. Now I have to go find it. So this goes in exec. This is in function.go. So we'll have, I guess we'll put them in alphabetical order. Mod function exec/function defines the function type of binary, not both bool. Left string right string. I guess I should probably be copying and pasting this stuff, but that feels a little bit worse than typing it again. Vec expr locals vec string globals vec string. Vector of expressions. Now, what's an expression? This is vec. This is in the value module. Yeah, there we go. Pub mod value. Look over here. This is in value/context. Value con. Oh boy, we got context everywhere. Okay, this is pretty short. I'm not going to make another module for that. I think maybe these aren't really supposed to be modules, like exec context, but it's in a different file. And I think the way we do that in Rust is to have a module. Yeah, I don't think so. Rust multiple files without module. Yeah, Rust has no module, or no, no knowledge of files. Yeah, we only know about modules. Okay, so we'll do this. It's fine. Pub mod context contains an interface. Oh, a trait. We've got a trait. Pub trait expr string returns the unambiguous representation of the expression to be used in program source. Okay. Prog string eval takes a context. Oh, whoops. Context. Probably should take a reference to a context. And returns a value. Okay. Exec context. And it returns a super value. And now it's going to be mad. We've got generic arguments. Okay. We'll come back to that later. Function. Where do we define function? We're really all over the place here, aren't we? And opdef. Two definitions. What the heck? Well, which opdef is this? We're in context. present in two files, exec opdef. Oh, then it must be the definition here. Because we're in exec, yeah, opdef. Okay, we're not going to make a different module for that. Struct opdef. Okay, this looks like it might be an enum at some point, but we'll see. Okay, opdef is taken care of. We've got our context. Great. Oh, what's this? Ooh. Okay. Oh, this is gonna be rough. Hold on. Body. Done with opdef. Done with opdef. Value expression. Is this a trait? Ugh. Now, should it be a boxed-in expression? Let's try. Yeah, we'll try this for now. We might have to box it later. It can't be made into an object because of something I don't remember. Why can't it be made into an object? Cannot be made into an object. It needs to allow building a vtable. Oh, I forget. Oh, I think it means it can't have any. It can't have any generic. Cannot be dispatched. Non-methods can't be dispatched. Generics are not compatible. Okay, but we can put the generics actually on. Okay, so this has to take self, and this takes self. And we can put these generics on the type itself, I think. And now I think it's okay. Yes. And we already have the tick A. Except this also has to be, yeah, O, E. Well, I'm glad I'm doing this actually because this will probably give me my. Why isn't it used? What's it meant? What's going on? Expected comma? What? Expected type. Oh, I forgot this. Yeah, because I haven't had any like complicated lifetime stuff in any of the Rust I've written before. So, this might be my first taste of that. Okay, this looks great. Multiple fields, perfect. Those are the kind of issues we want to see. Okay, so where were we? I think we were just doing context. We've got our context all set up now. And now we want to generate a new context. Yeah, I actually I do feel that Rust feels quite complicated to begin with, um, which is actually why I learned Go first. I really liked the emphasis on simplicity in Go, um, but once I got kind of used to that, I really enjoy um, the expressiveness of Rust. Like having more things at your disposal is pretty cool. And I also feel like you can. Well, it's also so there's like the expressive power, which feels like it gives you more freedom, and then at the same time there are like more constraints that you can place on yourself, um, which makes me feel more confident in the code I write. So, for example, um, I'm gonna have to mark stuff that I actually want to mutate as mutable. So right now, I mean, we don't have anything that we can mutate here. Whereas in Go, I mean, I have no idea, especially these pointers. I'm assuming that they're pointers because we're going to be mutating things. Like looking at this Go source code, I don't know what's going to be changing as the program runs. We've got like these global values floating around, and I don't know if they're going to change. And also, um, getting back to the expressiveness, we'll be able to probably use things like enums to make some of these things more clear. So, in the end, I feel that Rust is definitely more complicated than Go, um, but I like the trade offs it gives me, like the greater power it gives me for that complexity. Yeah, I mean, Go is fun. I really really liked Go. Um, but now it's hard to go back to from Rust. Let's see. So we just need a new context. I also didn't like, just visually, I didn't like how Rust looks. You know, you've got all these different characters. I mean, Go just looks so clean. Almost kind of like Python a lot of the time. The other thing I really like about Go still is how much stuff comes in its standard library. Like in Rust, you saw we already had to go and get like an external crate for random numbers. And you need external crates for regular expressions, for um, during the work week. I've also been working on a new web server for our group's website. I had to go and get a package for an HTTP server. I had to go get a package for HTTP requests. I'm having to. This is probably stupid on my part. I should have gone and gotten a package for HTML templates, but I'm just doing it with like string replaces for now. Whereas Go has all of that built in. When I built the server for my personal website, it's like, okay, I use the HTTP package that has a great server in it. I use the HTML templates package for doing my templating. When I'm writing parsers, I just use the regular expressions built in. So Go's really, really nice for that kind of thing. Yeah, that's true. I mean, you could call Go's standard library bloated. And I think that's basically what Rust goes for, is they want like a stripped down standard library. Um, yeah. Definitely true. It's just a design decision. Um, okay. So yeah, let's go ahead and make a context. Okay. Impl context pub fn new. Conf. Well, we'll just give it the actual name here. Yeah, let's take a context. No, config. I think, yeah, that's all it takes. It returns a self. Yep. takes 2 generic arguments, but 2 were supplied. Oh, this one. Let's see. It still looks mad about that. I'm not really sure why. Do I not have to put it on the config here? Alright, what's it mad about? Add missing generic. What? No, that's definitely not right. Context. Implicit lifetime. Okay, I've got the generics are right there. What's going on? Associated type bounds are unstable. Oh. This is just supposed to say OE, I see. Whoops. OE. Self. Config. Frame sizes. I guess is just a new vector. Stack. New vector. Globals. Make a new. Okay, hash map new. I think the same thing. Sorry, just responding. Alright. Yeah, this is kind of nice, right? That we specify the type up there, we can just call hash map new here, whereas you have to like make the map. Defs, new vec, and this is new vec. Okay, great. Tidy that up, and everything looks okay. I don't know if I'm gonna do these like getters and setters. We might just access the fields directly. We'll see. New context. So, well, okay. I guess we can just run straight down this and implement these functions. Maybe that's the best way to go. So let's go ahead and factor this out to a file. Exec. And we'll do the same thing here. Yep. And then we'll go down to context. Okay, great. So we're off in our own file now. Let's just save all the files. Okay, well, I guess we'll just copy the interface. So let's get a getter method. Whoa, that doesn't look right. Whoa, why did that happen? I guess something with my snippets is really messing up here. Config. Set constants. I mean, so clearly this has to be mutable. Constants. Oh boy. C assign global. Alright, yeah, we'll just run down it and do this. Pub fn. I think this one's not pub, right? I know it is pub. Pub fn. Set constants. Ref mute self. And we're supposed to check F64. Oh boy, I don't know about this. We'll see if this works. Standard F64 const E. Why even bother? Pi. Yeah, just don't even bother with that. So we're gonna do C self dot assign global E2 standard F64 consts E, and we'll do the same for pi. Okay, obviously these don't exist, so we'll generate it. Ref needs self. I think it doesn't. It's not going to return anything. All we do, arg e. Okay, we're going to change those. This is going to be slightly annoying because my hash map, the keys are strings. Maybe we can make them like refster. Bad example to user should copy the example. A bit more noise. It's clearly better. It'd be nice to make it generic, but I don't think we can. Okay, so assign global. We just take self dot globals of arg e. Oh. Oh, great. Oh, that's really good. Now, it's supposed to be a value. Oh, boy. How do I turn this into a value? Ah, okay. Oh, God. What is a big float? Let's go look at a big float. Oh boy, it's just a pointer to. Oh, it has an embedded big float. Did I say what value is yet? Value. Pubstruct value. Okay. We're gonna try it like this. Value. Oh boy. Yeah, we're having we're having trouble already. Const returns a big float. I just need to go look at what a value is, I guess. Value. Oh my. What is a value? Oh. Inner is a value. Oh, duh. Okay. To type. Oh, it has some kind of type. Value type. Okay, so I think this is an enum. Alright. I don't like this. Whoops. Value float. What's wrong? Cannot assign to data. Hash map. What? Index mute. Whoa, that's that's not good. Kind of confused here. Oh, what? Index mute not implemented before. Oh, it's actually just not implemented. Wow, okay. So we need, I guess we have to call dot insert. Oh, now I'm going to have to do 2 owned. Oh, okay. Cool. Okay, so value, yeah, so actually, this is something I run into a lot, actually. The difference between using a trait and using an enum. So if we use a trait here, then my vec of values will have to be globals symtab value. Then my hash map of value is then, this is going to have to be like a trait object. This has to be a trait object. And we're going to have to do like den here. Whereas if we use an enum, we can just define these as methods on the enum, and we'll do the match inside. Oh boy. I never know which to do for that. I guess maybe we should just try sticking with it this way. Maybe we should try to copy this way. But it's sure nice to implement things separately, right? Instead of matching everywhere. Oh, man. I usually go the enum way, so let's mix it up. We'll do this. We'll do it like this, I guess. Well, but then we have to like implement value everywhere. Let's look at their code. So for example, yeah, you go to big float. Type big float is just a float. Yeah. String, sprint f, prog string, to type, switch which, pretty funny. Enum retreat, enum retreat. Let's see what people on the internet say. I've read there's like a, yeah, enum retreat. Oh no. Different layers. Enums are concrete instances of a type, whereas traits are abstract sets of types. Yeah, okay, an enum closes the universe. There are only 3 shapes. A shape trait defines what qualifies something to be a shape, ignoring whether any even exist. So, do we want to enumerate the possible values? Or do we want to say anything can be a value? I mean, going by that, I think it's clear we want to enumerate the possible values. If it's something from a predetermined set, use an enum. If people agree with that? You know, close to the type, close to the properties. But do we want things that we can treat as values? We don't care. We'll just go with the enum. We'll just stick with the enum. Okay, it's fine. Stick with the enum. Now, where do we come from? Back to context. Yeah, switch which is pretty good. Context. Where I got completely lost in all of these tabs. Switch, context. Okay, yeah, we need to go back here. Set constants. We just set these constants. We did. Yeah. Okay, we'll get a sign. So set constants. Now we're supposed to have global. Pub fn global takes a self and a name string and returns a value. Yep. So we don't have to say return in Rust. We can just say self.globals of name. Value is not copy. Clone, copy. We might not be able to do copy later. If these become more complicated, they might not be copy anymore. Okay, now it should be fine, right? Now the other thing we could do is we could do get name, in which case we would return an option. That's probably the safer thing to do, right? Option ref value. We'll see. We might come back to this. And now it doesn't actually have to be clone and copy, because we're returning a reference. We'll see later which one we actually want. Okay, local. I guess we need to be copying the documentation as well, right? Okay. Sim tab is a symbol table. Whoops. Pubstruct. The only implementation of value context. Wait, it's supposed to be a trait? Yeah, okay. Config is a configuration state. Access through value.context config method. Value.context through the config. Actually, we should probably use this, right? Does that link you to it? I think it links it to it. Did I delete the definition of SymTab? Oh my god. Hold on. No, I thought I accidentally copied that. Okay. Alright, fix that. Frame sizes. Each stack frame on the call stack. Unary fn. I forgot to copy it again. unary functions to their implementations. This is the same for binary. Yep. Defs. Defs is a list of defined ops in time order. Okay, I understand what that means now. This is just in the order they were defined. It is used when saving the context to a file. Names of variables declared in the currently being parsed function. Great. Okay. Config, okay, reassigns the fundamental constant values. We don't actually have a floating point precision. I don't like repeating the name. I know you have to do that in Go. Constant values. We don't have the precision, so don't say that. Oh, actually, we do have the. Well, we don't use it actually. Yeah, we're not going to worry about the precision, I think, because we're just going to use floats directly. Global. Or nil if the symbol is not defined. Ah, okay, great. Oh, so it is nil. So yeah, that should be an option. It's a good thing we went with the option. Returns the name of a global symbol. Or none if the symbol is not defined. Yeah, makes sense. So the thing with assign global must be defined. Assign assigns the global variable the value. The variable must be defined. We don't have that restriction, right? Like it's just going to insert it. Now we do have an option here, because when you do insert, if it didn't have a key, so if it already had the key, we could return the old one. I don't think we're going to ever want that, which is why I'm not returning anything now, but it's something to keep in mind. Assigns the global variable the value. Oh, this is supposed to say value, I guess. Oh no, name. This is name. And this is value. Oh, this is actually supposed to. Oh, whoops. Yeah, this is actually supposed to take a value. And this is supposed to say value float. Sometimes I hate how it completes stuff. Value float. There. Okay. And then similarly we got this. Global. Why did I do that? God, just no, I should not have copied the whole thing. Okay. Assigns a local variable with the given index the value. I'm guessing that this index is like the level in the stack, I guess, like the call stack. Of fn global, nope. Assign local referee itself. Size value self.stack of self.stack.length minus I equals value. That's always kind of funny, right? Like I can't call length, because this takes an exclusive reference on the same line that I set this, because this takes a mutable reference. So it's like I take the mutable reference here, so I can't take an exclusive, an immutable reference farther down the line. Always funny when that happens. Okay. Or sorry, I got that backwards, right? This is the exclusive reference. This takes an immutable reference. Okay, assign local. Now we need actual local. Which is, oh, it's kind of funny. Global local, then you go local global. But whatever. Pub fn local self. Yeah, we have to take I this time. Returns, I think. So this doesn't return an option apparently. We'll see about that. Self.stack. This is not a value, is it? Oh, it is. Return a reference. Local, assign global. Push a new local frame onto the context stack. Okay. Oh, I guess I should document this. Local. Yep, just messed that one up. Returns the value of the local variable with index I. Oh, that's where the, okay, sure. Push. Now this is not pub. Okay, fn push. Mute self. It takes a function. Oh, we can't call it that. Let's just call it fun. So we're checking if the capacity, while the capacity of our stack is less than n plus the length of locals, we append c.stack equals append c.stack up to the capacity of the stack nil. Oof. Wow. Up to the capacity of the stack. C.stack equals append. So we're slicing the stack up to its capacity. I might have to draw a picture to figure out what's going on here. For capacity, C.stack. I mean, I understand, why can't you just do like a resize? Okay, the capacity of the stack is less than the length of the stack plus So just setting the capacity, right? For the capacity of the stack is less than the length of the stack plus the length of the locals. We're appending nil yeah, I mean we're just like resizing the stack, right? And filling the gap with nil. Okay. I kind of think we can skip that. Does Go not have like a... I guess Go doesn't have a set capacity, right? But I think Rust set that capacity. I think we can actually do that. We can like resize it with capacity. Set length. Oh, it's unsafe. We can probably skip this, right? Yeah, resize by filling with the value 7. Yeah. Okay, I think we can just resize, right? Plus length. For the capacity is less than. I think we can just resize it. C.stack. Oh, not C. What? Self.stack.resize. Why is it only resize with? I don't know why it's resize with. What? Isn't stack a vector? Yeah. Oh. I see. Yeah, it wasn't offering me resize because I have to provide a value. And I think value, yeah, value has to be clone. And probably it knows that value is not clone. Okay. Can you not just like set the capacity? Capacity. Vec.capacity. Because it seems like we're just reserving space. Oh, reserve. Reserves capacity. I don't, like, why are we doing this, though? Like, can't we just push to the... And why are they checking the capacity? Like, this would make total sense. I've written this code before in Go if this were length. If this were length, I would totally understand. C.stack equals append C.stack. So we're slicing up to the capacity and we're putting in nil. We slice up to the capacity, we put in nil. I think this is like some kind of optimization. And I think we can just skip that. Self.frame sizes dot push fn dot the stack. We're slicing the stack in plus length fn locals. Why do they do this so many times? Why did this happen? Oh, okay. Self.stack equals self.stack plus alpha. Yeah, not so sure this is gonna work. Oh boy. Tick A. What are we in right now? Oh, okay, we can just pass this along. Tick A, O, E. This is so weird. I don't understand this at all. So maybe we do have to do this part. We're filling it with nil. I can't fill it with nil. I'm gonna have to fill it with like none value. C.frame sizes plus link FN local. So I'm gonna have to go back to my value, and we're gonna have to have a none. Yeah. Self.stack.resize with n plus. Wait, what are we're supposed to set the new length is n plus lfun value default. Oh, wait, what is this? It's supposed to be a. No, it's a vec of value. What? Oh. Oh, okay, duh. Jeez. Great. Wait, but I resized it to this. What? So why do they then c.stack equals append? We're slicing up to the capacity. I'm not sure. I'm not sure. Definitely I don't need to do the truncation though. Okay, not sure about that. Push pushes a new local frame onto the context stack. Pops the top frame from the stack. But it doesn't return it, it just like deletes it, I guess. Doesn't this have a pop actually? I can just self.framesizes.pop. Removes the last element. Yeah. Frame sizes and stack. Stack. Yep, just pop them both. No problem. The top frame. Okay. Pop. Pops. Top frame from the stack. Evaluates a list of expressions. Yeah, I mean, so this all makes sense. So you have some context, you have a list of expressions, you evaluate some list in that context. Fn eval self. So we're in the context, of course. We have expers, which is a vec of exper. Whoa, what just happened? What is this? Why did it? Oh, that's annoying. Anyway, eval, and it returns a value. Oh, yeah, I guess it's a trait. Ref den exper OE. That doesn't really seem right. Why does this have to have OE? Oh, because of the oh my goodness, it's kind of weird. It feels a little circular, doesn't it? I guess not. For expert and expers. V let me equal expert dot eval if v not equal nil. Okay, so this is going to return like an option. Okay. Oh, it's supposed to take an argument? Oh, in a context, of course. And this is supposed to be pub. Now, of course, what this actually translates to is expers.iter.flatmap e.eval self.collect. Because we were just doing this, right? Sum b, yep, flatmap collect. That should work. Eval unary. Hi. Okay, this is very similar. Oh no, it's not that similar, but let's see. Pub fn eval unary. Let's see, binary unary. Okay, so op is a string. Evaluates. That might not be what we want. Value.reduce. Alright, we'll see. Takes an op. This is self. Probably somewhere we're going to want the operator to actually be some kind of enum. Op string right. I feel like the normal thing to say is like RHS, like right hand side, but I guess we'll just call it right for now. Right is a value, and we're going to return a value. Self length up this is a little annoying. Alright, I'm gonna stop. We're just gonna call this L. Fine. Right. What's the problem here? Wait, it wants me to call reduce? Self.reduce. Yeah, I don't think I have that actually. So we need to go to the lib exec. We don't have a oh, we do have a value module. Okay, so this is just a top level function, reduces. Okay. E value, pub tree expression, use super value. This is just in the file. What file are we in? Value. Okay. Oh wait. What was it? Eval. File value eval. Oh god. Pub fn reduce takes a context. Now the context, yeah, we're gonna have to copy this. Yeah, it has to take a reference to a context. It takes an op, which is a string, and it takes v, which is a value. It returns a value. Nope. IO, right? Super value. So we do that just so we can actually import this. This is supposed to take a string. And actually we can make this take a str. Okay, that should be okay. What's the problem here? We need, yep. What? Cannot be in Really? This? No. I don't want it as bytes. Goodness. Yeah, okay, I guess I want this. We'll just unwrap for now. Well, oh, this is just last, right? L minus 1 dot last. Well, that's actually nicer then, isn't it? Can you do that? No, that's fine. Turn, scan, self, L minus 1. Okay. And we'll go back over here and do scan. Here's reduce, here's scan. Context, an op, and a value, returns a value. Great. And this, why is that? Oh, it's because this is being returned as the expression. Okay. Let on equals c dot self dot unary up. No, oh god. Nil. Pub fn unary takes self and an op returns a unary op. Oh, whoops. It actually will be an option, I think. Let's go take a look at this. Yeah, so this is in value context. Oof, another trait. Where is expert here? Face. Expert's up there, so put it down here. Pub trait. Unary op. It just has an eval unary. Takes a context. I should have just copied this whole thing. Self, context, right. How do we call this? It takes an op. We'll just call it fun. Well, we'll call it, sure, user fun. That's what we want the users to have, is fun. So return some user fun. Oh. Why are you mad about this? Oh, of course. Unary ops. Oh. Unary ops. Oh no. Make string. Yeah, so this is like a, oh man. Alright, so for this we're gonna, oh boy, we're gonna have to bring in lazy static, I guess. What is this in? This is in value unary. This isn't, yeah, this is not going to be the permanent definition. But hopefully it'll work for now. This is not good. I don't think we want this to be a trait, actually. Ah, boy. Let me... So what is it? It has to have... Go to unary. Where's our trait? Eval unary. Ooh. Oh, duh. Context, square root. I'm just wondering if we can make this an enum as well, so we don't have to deal with this like trait object stuff. And also, shouldn't this take... It takes a value. But if it's a unary operator, why does it take right? Isn't right just self? Like, it is its own thing. Unary op. Why do we even have to have this as a trait? Why is it not just a function? What is my value? Is my value an enum? Oh, my value is an enum. Okay. So I think the fact that our value is an enum... Yeah. Okay, no. This is just a method on... This is just a method on... Wait, what is self here? Unary op. Okay, we don't need this. We don't need this. Yeah, this is just, what does this go with? This is supposed to close. What? Wait, where is this? Oh, I messed something up here. Okay, hold on. I think that's supposed to go like that. Yeah, okay. Okay, hold on. This is just going to be value. Yes, it takes a self and a context. We just evaluate ourselves in the context. This closes that, this closes that, this closes nothing. Okay, now we need a context. Um, oh wait, hold on. Hold on. But where is the eval unary? Eval, call reduce, scan, reduce, scan. Eval. Oh, why are there so many different definitions? I'm kind of scared. I think we only care about this one, right? Eval takes a unary op. All right, I'm a little bit confused here. Let's go back for a second. Unary op. Where is this trait? Interface implemented by a simple unary operator. Okay, we'll just do it like they have it here. Well, yeah. Did I back up far enough? Okay, I think, okay, we want this. Okay. This is not going to go well. Okay. Takes two. No. Oh. This is just supposed to be like this. Now I'm supposed to define these somewhere. Oh, maybe I just have to do this. Is that right? Right? Oh no. Okay. Trait bounds on static rust. Oh, maybe the issue, we might just have to do this. I kind of wish I hadn't done all of these generics, right? Yeah, it can't be, of course not. So what's the problem? Can't be shared between threads. Makes sense to me. Okay. Yeah, right. This is why we went back towards the enum thing. Unary ops. Okay, maybe I just hold off on this for a second, because I'm very confused. Okay, let's just undo a little bit. Yeah, we're gonna hold off on the unary op. Let's go back over here, and look at this for a second again. Okay, I'm trying to do this in context. Eval. Okay, let's just go back for a second. Try to figure out what's going on. Alright, let fun. Okay, yeah. We're gonna hold off for just a second. We're not gonna return anything yet. I'm just gonna say to do. Okay. Let fun equals self unary op. Okay. Dot unwrap. Okay, hold on. Let's undo a little bit again. All right, we need this option. Go to unary. If let some user fun is self.unaryfn.getOp, that's fine. Is this all good? Unresolved import. Okay, I need to go back over here. Well, actually, I think I need to redo, right? Okay, we got a little carried away here. We can just do that for now. Okay, good. That's what we're working on right now. I think the LSP is very upset right now. Okay. If let some user fun return some user fun. Otherwise, we have to check built-in. Right. Okay, and that's why I was trying to do this. Yeah, value. Unary ops. Take me to the definition. I wonder where this gets loaded. I bet this is where you probably read it in from like the Ivy file. Oh, but I really don't want to make a hash map of trait objects. No, we want to look for RG eval unary because these implementations context assign local eval function body. Yeah, this is another instance of the enum versus interface thing. Should we define the... If we just define unary op as an enum, I don't understand what could go wrong if we do it as an enum, right? Like, where else is it even defined? So we have it for a function. I don't really understand why there are these different things either. Fn eval. Where does Fn come from? Oh, this isn't. Yeah, right. Eval unary. I mean, it just takes an operator and a value and applies the operator to the value. Okay, so this, what is C here? It's a unary op. I don't know. So what unary ops? Is that over here? Unary ops. String to a unary op. I think this might just have to be an enum. Otherwise, it just doesn't even make sense. Because we can't, I don't think we can do this, right? This is new. I've never seen this before. Display. Never show view frame. Wow, this is great. Yeah, no. I don't know. I'm not sure where this came from. I think we're going to do unary op as an enum as well. Yeah. Yeah. All right. Just forget it. Enum. Unary op. No, we don't have any yet. Impl. Unary op. And we can just call it eval now. Yeah, I think we got too many of these. Take self, context. Yeah. For now, it just returns none. Yeah. Do we want it on this or do we want it on eval? Probably we want it on eval. Oh, right. Great. Okay, so now we can at least write this code. Great. Okay. If let well, this is a bit stupid, right? We should be doing, I guess we should do this. It doesn't really matter. I guess this is slightly better, right? Because it just seems dumb to like unwrap it and then like wrap it again. Basically, oh man, basically what I want like the opposite. Ooh. Found enum. Okay. Guess we'll just return this, right? Yeah, it seems dumb to unwrap, rewrap. Now user fun, oh, this is why it's an, okay. Alright, I see now. I think it does need to be this. Pub trait, I deleted the wrong thing. Unary op. Eval, what is it supposed to be? Eval unary? And now we can't have this. Yeah, I'm gonna have to. This isn't gonna work. This isn't gonna work at all. Yeah, probably don't need lazy static here. I think, yeah, what we're gonna have to do. Okay, I know what we're gonna do. Where do these come from? Oh, there it is, init. Jeez. Ops in unary op. Name. Yeah. Okay. Okay. Jeez. Why is this generic? Oh, it has to be generic on the context. Oh, no. This doesn't have to be generic. Oh, jeez. I'm an idiot. Alright, there we go. Make this generic. And then this doesn't need this. Okay. Treat objects. Din. There we go. Do I even need this now? Whoops. Okay. Now we're good. Okay, I was just being super dumb there. And then eventually, we won't do this in a init, we'll just put it in here. I guess, maybe in Go you can't have a literal hash? I'm not sure. Okay. And obviously, I mean, this can't be, actually, we can make this static. And then when I want to do this, we can just say, let's do pub fn unary ops. What is that noise? Pub fn unary ops. It's going to take whatever this is, stir. Op is ref stir. And it's going to return an option. Well, we'll just see what it returns. Unary ops get op. Did I just write something weird? Whoops. Unary ops of op. There we go. Then the size, and I know at compile time. Okay, that's why it has to be a ref. Cannot be made into an object. Oh, now it can't be made into an object, of course, because I moved the generic onto the function. Which is probably why I had it like that before. Now we can make a trait object, but now I don't have the generics. Oh. Whoops. Okay. Is it possible? Can I make this generic? I don't think so. Oh god, watch this. Alright, why can't it be hash map cannot be shared between threads safely? Help within is not implemented. Okay, string static unary op static. Oh, okay, hold on. I think we can fix that. Impl send for unary op. I think you have to do this. Impl send for tree. I don't think, maybe you can't do this. Send and sync. I think basically it's telling me that this is just like not a static, maybe. Trait objects. Aren't these automatic though? Oh, here we go. This is my question exactly. Probably it's going to say it's a dumb question. Oh. Pub trait has to be sent. Cannot be shared. Oh, is this supposed to be sync or send? Maybe it's supposed to be saying shared between sync. Yeah, sync. Yeah, I guess we don't need it to be send, we need it to be sync. Oh, great. Oh, yes. Okay. Found enum. Wow, that's a wild type. Unary. Can I just take that off? Okay. That's a little wacky. Not sure about that. But maybe it works. Okay. Yeah, that's right, actually. Return built-in, none. So we first see if it's a user function. I mean, this sure looks better though, doesn't it? Oh. Yeah, okay. I guess we'll go back to this. If let sum built-in equals this, and I return some built-in. I have to do this maybe? What did it tell me? The trait bound is not satisfied. Value context unary op. Oh, okay, that's actually expected. So this returns a function. User fun is a function. Function. Okay. Impl unary op or function. I see. Okay, this is all starting to make sense. Tick A, O, E. Okay. Implement missing members. Great. To do. Why is it mad? Missing. Oh. Good lord. expert is not send and sync. Great. Okay. Then expert plus sync. Okay. So this, I think we're gonna have to box it, right? Box in. Yep. Great. And now we don't use the tick A. Okay. I think we don't need tick A anymore. Take 0. Perfect. Remove this. Mismatch types. Right, okay. Well, let's double back to that for a second. Okay. And then we just return fun.eval unary. C is our context. Self right. Okay. Oh, we unwrap it. Unwrap. I guess it's supposed to be an option. We'll see. We might be able to get rid of some of these options later, but I'm not sure. Now this has to return an option. Why does this? Well, because it's possible that we return. Oh, if it's nil. Okay. No. This needs to return a value. This needs to return a value. This needs to return a value. Unwrap. Okay, let me get rid of this warning. Okay, now we need to implement it also for whatever built-in is. What is built-in? Unary ops is a... Wait, it is a unary op. What the heck? What? Help, the trait is implemented, okay, is not implemented for context unary op. What? What isn't this context unary op? Pub trait unary op. What? Unary ops. Returns. Oh my. Hold on. Hold on. Okay. Let's take this just a second. This is context unary op. What unary op is this? This is an eval unary op. Okay. No. This is supposed to return. Okay. I see. Unary op. Okay. Ops. You put these in. Okay. Okay. Hold on. Okay. The trait bound is not satisfied. Function required for the cast from din. Okay. This returns like too many dins, I think. What's wrong with this one? Something gets mad. Oh, of course. Yeah, because this returns a value. Yeah, we're just going to wrap this as well. Oh. Okay. Some built-in. The trait bound is not satisfied. Let's run this again. The trait bound is not satisfied. Okay, built-in gets returned by this. Ref den. This. Not implemented. The trait value context unary op is not implemented for ref den unary op. That's interesting. Well, okay, let's go back. Unary op, we're looking at unary, built-in, unary ops. If it's not nil, we just return it. It's supposed to return a value unary op, where self is sync, O right, E right. Okay. I'm really not understanding this error message. It looks like I need to return like a concrete type, which makes sense. Ref den unary op. We're supposed to just look it up in this thing. So if I go to values, this is values unary op, right? It's got all this stuff in it. Okay, unary op. Make map of string to unary op. Oh, but wait. I don't think that's right. Value, package value. Oh, we're in package value. Oh, okay, yes. So this is package unary op. This unary op is from value. Value unary op. This is insane. Value eval. Okay. I think this does have to be din though, right? I don't understand. If I just make this pub, does that work? No, it still doesn't work, right? Okay, I just want to make sure that it wasn't some weird indirection with the yeah, it's not satisfied. It's implemented for function required for the cast from din value context unary op to the object din value context unary op. Wait, why can't I just return? Okay, hold on. If we just do this, let's take this. Maybe we have the wrong type here. We might be close. Okay, it says that this is a ref. I think that's the problem. Option. If I said ref den unary op of. Okay, so this is obviously wrong. Is this okay? Oh, but it found tick static. Oh, that's why. Okay, this is the annoying. This is very annoying, actually. I think I need to get, like one layer of that off, right? What does this suggest that I do here? As dref. Can I do that? No. Mismatch types. Expected this. Found reference. Help. Use copied. What? This type parameter expected. Oh, found reference. What? Sure. No. We want to go back here. Unary ops off. There. Oh boy. Okay, let's go back to lib. I think these need to be. Can I just make this O E pub static? Yeah, I mean you can't have we can't have a generic. Like where would it get the values from? Okay, so these are dynamic. These are den. Can I just make this den as well? Right. This is not good. Now user fun doesn't work. Yeah. Unary FN. I mean, why does the function have to take this? The function has to take it. Now does okay, if function doesn't need to be an object, do we have den function anywhere? But we're gonna have to have den function, right? Because this is a map to function. Is function, oh geez. No, I think a function. Okay, it looks like function does not have to be. Okay, we're not doing any den functions. So I think we can make function not generic. Box expression. Oh god. But now the expression is generic. Why is the expression generic? We probably do have den expers, is that right? Yeah, we have to be able to turn the expression into an object. Wow, this is a mess. This is a mess. Okay, so we fixed this one. Yeah, maybe... My goodness. I kind of hate to keep doing the den stuff, but I mean, that's just how Go works, right? Like everything, these are just objects. All right, this is gonna be ref. We'll just do this, I guess. Ref. Now, what is wrong with this? Take a not implement. Oh boy, missing lifetime specified. I liked that. Like, that's nice. Oh, but function has the generics. Oh boy. Oh god. Some built-in. Yeah, we need some way to get these built-ins, right? We need some way to get these out of the hash. Do they put more things in the hash later? Oops. I guess I should stop closing this terminal. I keep hoping I'm done with it. Unary ops. Built-in. Unary ops. It looks like... Yeah, you only... Okay. No. This only gets constructed once. Access, make op. Okay, no. This, we can just make this, these are concrete types. Unary ops. Yeah, these are built-ins, my goodness. Let's just keep going. We need this type. This is the unary type. My goodness. Okay, this is the type. Where is this? How did we get here? Who am I? This is value eval. Okay, so we're in the value module. Pubmod eval. Good lord. All right, struct unary op. It has a name. String, element wise, bool, and oh my goodness, something we don't know. Unary fn func fn. It's a vec of fn's how do I do this? A vec of f. Okay. F is fn. Oh boy, this is a mess. A real mess here. This over here, unary op. It's an fn. Oh man. Of context. Nope. Value to value. There's basically no way this is going to work. OE. O is right, E is right. What? It's used right here. Oh. Oh my god. Wait, I think we have to say that this is generic over this. Yeah, no, maybe not. Hold on. We have to do this. Where? Does that work? No way. I don't understand this at all. Parameter O is never used. But they're used... Maybe you just can't do this. That could be possible. I shouldn't have closed all of that. I just gotta clear some of this stuff out. Call with one F. Generic over generic function Rust. I don't know if you can do that. Generic closure argument Rust. No, you can't. You can define a generic closure. What you can't do is create a let binding with a generic left-hand side. Okay, is this going to be impossible? I might just fn num type unary fn. This is what we're trying to do. We're trying to make a unary fn takes a context. Okay, maybe we have to do it like they do it in Go. Okay, let's just say, hold on. Let's say type unary fn is an fn of context value. Okay, what's wrong? Then context. Oh, right. Associated type bounds are unstable. Okay. So we say this is dead. We have to do this. Can't do that. Oh. Can I do that? This is looking promising. Does that work? That works. F is a unary fn. Okay. Yeah. Okay. Oh wait. Dummy. No, this is just a vec of unary fn. What's wrong? Right. Yeah. DIN. This. Actually, these are going to be tick static, right? Yay. Okay. Great. I guess. Does this compile? Almost. Oh, yes. Now I go back to lib. Okay, now I go down to this. And it's no longer DIN. Now it's actually a hash map of these unary ops. Yeah. Pub. Now, no, it's a different unary op. It's actually, it's this unary op, right? Value eval unary op. Super value super eval unary op. Expected trait found struct. Yeah, now it is, it's just unary op. What's the problem? I'm missing some generics. Okay. Whoops. Okay, and now this has to be generic because why? Unary op, because the function has to take a context. Oh, I hate the stupid context. I just hate the like output and error thing. If it weren't for that, everything would be so easy. If we could just get rid of these generics, everything would be so easy. We wouldn't have this crazy trait bounds everywhere. Okay. I wish I could just specify this later. Option unary op. Yeah, you know what? Let's just get rid of the hash entirely. Wait, why does this just not take a context? Because if this took a context, we could get the bounds from the context we pass in. Yeah, that might be the way to go. Maybe it'll make more sense if we actually put some of these in. Let me undo that. Yeah, op.name. Okay, great. Wait, name equals op. Non-type. Oh god. Oh, it's supposed to be a vector. Oh yeah, it is a vector. It is a vector. Int type, new complex. Oh my. This is an absolute nightmare. Got these types. Yeah, I think this is the point where probably we're doing something wrong. Like the implementation should be different in Rust than it is in Go. And copying just trying to copy the Go implementation directly is probably not the right way to go about this. That's the sense I'm getting. We probably just need to like rethink it in a Rusty way. And the other thing is that we're running into these types that maybe we won't even really have. Unary ops. Hash map. Maybe we just don't need this hash map. We do need some way to look up a built-in operator. And maybe the way we do that... Yeah, wait, okay, hold on. All we're trying to do is look up a built-in operator. That's the whole... Alright, hold on. Okay. I'm going to go ahead and commit this. Initial commit in the middle of broken unary op stuff. Okay, that way we can come back to this later. And I'm going to go back over to my context. And when I'm doing this unary, all we're trying to do here is look up a built-in operator. So I'm going to go over here, and really, I think all we're trying to do is convert from string. So we get, what is a unary op? Let me go back to built-in. Where is built-in? Unary. Okay, so what we're going to do, where do I want to put this? Somewhere. Yeah, forget this. What we're going to do is we're going to have a struct built-in. We're going to impl unary op for built-in. Okay, and we're also impl from stir for built-in. Okay, this is not a struct, this is an enum. Yeah. Okay, we're gonna come back over here. It's an enum. We want to just put some in just to see what they look like. Unary built-in. We'll start with question mark. Sure. Cute. I wish we had like the word name. Oh, I think it's called roll. Actually, why did I close this? IV. Roll. Yep. Type air equals. Parse point. Parse built-in. Fine. Match S. Great. Okay, now EO, unary op, Missing generics. EO. I guess I usually do it the other way around, right? Okay, now what's the problem here? Oh. Okay. Great. Okay. So, whoa. Shoot. Context. Okay. So, instead of calling unary ops, I think I can just delete this for now. We are going to try if let some built-in equals built. Okay, hold on. Pub enum. Okay, built-in from stir. Oh, try. No, from stir is fine. If let okay from stir op I need to return it. Oh boy. Okay, hold on. Oh. No, it still doesn't work. Consider bar. Oh. Yes. Okay, it compiles. Cannot return value referencing local variable built in. Oh, of course. I guess I need to impl built-in expected ref din unary op found a built-in. Oh, we might need. Okay. Let's just. I guess we need box. Box unary op. Box din unary op. Okay. Box new. No. What's the matter? The trait bound is not satisfied. The trait bound ref function. I'm a bit confused here. I think I need to like dereference this maybe. Yes. The type parameter E may not live long enough. Okay. I just want to get rid of these warnings so that I can go straight to the errors on this variable. This may not live long enough. Okay. I guess is it static? It will meet its required lifetime bounds. Yeah, but where is the requirement? Cannot move out of user fun, which is behind a shared reference. Why can't, can I not just clone it to owned? Box new. built-in from stir. But this one, yeah, the reason I didn't add the box is because I'm making the built-in in here, and then I'm trying to return it. So I can't return just a reference. May not live long enough. Why does it have to be static? User fun. So this, oh, okay, this one's tied to the context. I really feel like this unary op shouldn't be generic over this. But if I want, do I have like a vec of unary op? It's like I have to, does it have to be object safe? I think so, because I have to return boxed in unary op, which means it has to have the generics on it. Oh, it thinks it doesn't live long enough. Why is it defined like this? It would be really nice just to get rid of the O and the E entirely. Like, just use standard out, standard error. Where does this all even go? Sets the writer to which program output is printed. You don't, it's not even used anywhere. Is it? No. Output. Whoops. Whoops. No, it's not even used anywhere. My God. Okay. Forget it. Where's the context? Context. We haven't even written anything yet. My God. Okay, now this does have to be dead. Whoops. Ooh, my hand's getting tired. Do I need this? Okay. Now, let's look at this. Tick A context. Now, why does my context need a tick A for this config? Okay, makes sense to me. Self.unityfn.get. Okay, this returns me a function that is tick A. Okay. Okay, now we're still gonna have some trouble here, it looks like. Let's go look at this. Maybe we want to do it like this. How does that work? Maybe we need to give this a lifetime as well. Okay. Expected lifetime. Won't care about the lifetime here. Implicit. Oh. Wait, what? Okay. Lifetime doesn't live long enough. No, come on. Returning this value requires that tick A must outlive tick static. Oh, okay, here we go. Let's call the lifetime. Oh, whoa, 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 whoa. Still? Returning this value requires that tick A must outlive tick static. this is a ref function. Oh, what does this return? Oh, I bet it's this. No. What does this return? What is user fun? A ref function. Why is it not a ref tick a function? Oops. What's this type? A ref function global. Now, why is this not working? Let's go back. I want to go back to this for a second. Because it was giving me more information here. Returning this value. So this is tick 1. Requires that tick 1 must outlive tick static. To declare that the trait object captures data from argument self, you can add an explicit. Okay. Now it still doesn't like that. Lifetime tick A is here, but it returned data with tick 1. Okay, why is this not tick A? Maybe this needs to be A like this? There we go. Okay. Oh. Well. Okay. That's just silly. Oh, we compiled. Okay. Wow. Okay. So what did we do here? Okay, get rid of generic output and error on config. Makes everything much nicer. We'll just say makes much nicer. Makes. Can we squeeze it in? Ugh. Way nicer? Oh. Okay. Oh, the other thing I should do, let's go in here. Hooks, pre-commit. Cargo funct. Okay, nothing has changed. Okay, whew. So we did it. Well, we did something. Okay, now we can finally get back to our context. We got something to work. Unary is here. Where were we? Unary. Oh boy, now we've got, oh god. Okay, so we took care of Unary. Pub fn user defined takes self op string and is binary bool, or returns a bool. If is binary, then we're going to try to return self.binary fn dot get op dot is sum, else we return self dot unary fn dot get op dot is sum. Check if op has been defined by the user. Okay, user defined, eval binary. Takes a self, takes left, which is a value, takes an op, which is a string, and it takes right, which is a value, and it returns a value. Okay, great. Whoops. Okay. So here, if product of self, left, op, right. Value. And where do we put these other ones? This is in value eval. I already have mod eval. How many mod evals do we have? Oh, just the one. Alright, let's go ahead and put this in a directory. Okay. So we call this product. Take C. U value. Op string v value. Great. Go back to context. Import this. Okay. Else, we're going to let fun equals self dot binary, which is defined here, of op binary of op which says let user equals self dot binary fn dot get of op if we can use let else. Let user equal this, else return. Oh yeah, if user, no it is, it's if let. Everything is if let. Come on. You never get to use let else. What did we do for unary? It returns an option. Good lord. Alright, we're going to return the same kind of thing here. Alright, forget it. Just copy the whole thing. Binary. If let sum user equals self binary. Why do they... See, they called it user. Up here was user fn. Really, it should just look exactly the same, shouldn't it? We're going to make it look exactly the same. It used to be a macro. It's kind of sad I just copy and pasted that. Okay, now it's a binary op. Binary op. Which I'm going to have to go define. This is defined in value context. Value context. Pub trait binary op. Eval binary, which takes a context, right and a left. Yes, of course. Value. Right, I haven't actually returned it yet, but hold on. This needs to be a binary fn.get. Okay, that seems fine so far. Why is it mad? Oh, right. Okay, I need to implement that, of course. Built-in from stir. Oh. Binary ops. Okay, let's go back over here. This is a unary built-in. Yeah, okay, we're gonna have to go look at this. Value, binary. We just need an example of a binary op over here. J. Oh, the complex. Let's go with plus. Let's go with plus. Okay. And actually, parse built-in. Okay, we can leave that there. Unary built-in like this. I'm just thinking about making a separate module for unary. And it looks like scan and reduce are defined everywhere, right? Okay. Extract module. Okay. To unary. No files need saving. We're gonna make this its own file. Okay. And we can get rid of this. Okay. Now let's go to unary and save this. And this is not gonna work anymore, of course. This module is private. Oh god, it says mod name everywhere. Value. Eval. Mod name with unary. Oh. Mod name, unary, yes. Oh, jeez. Mismatch types. Okay, that's a real issue. We'll take care of that in just a moment. Let's go back to unary. I'm going to copy this to binary. What's wrong with you? Eval binary. This is supposed to take something else. Eval binary. Context. Oh no. Left. Eval binary. Fn eval binary. UV. Yeah, see, these are like right, left. Oh my. That's kind of frightening. Whoa. Right, left. See, it says right, left in the interface. Okay. Well, I don't know about that. Fn here is it's this guy, a context binary, which returns a value binary op. Now, if we go a value binary op, value binary op, where do we get, hold on, unary op, unary op. Oh, that's what we did. Yeah. Unary built-in binary fromster. Okay. Now we got plus. We get plus. Here's our first binary operation is plus. I mean, where else do you start, really? Great. Okay. Now we come back to context. Go back down to binary. What's the matter here? Oh, I haven't implemented this yet. Okay. Struct function. User binary fn. Yeah. Is binary. Yeah, so you see, this might even be like an enum, right? Because if it's, or these are options at the very least, because if the function is binary, then we need to have a left and a right. Whereas if it's not binary, we only have one of them. So we're going to do impl, probably going to do the same thing. Binary op. There. This should be okay, I think. Binary built in. Okay. Yep. Where's my eval unary? Wait, I think we want unwrap or else. Mechanic unary not implemented. Can I do that? What's the matter? Closure, take 0 arguments. We could use it let else. Oh. For some reason it wouldn't format that, huh? I thought, let's see. What file equals self.unary op. One.unwrap or else. What's the one that takes, it must be the error one. Maybe error unwrap or else takes the, yeah, it takes the error. Oh, because this just gets none. That's why. I see. Well, all right. We got to use let else. Fantastic. Now let's hop down here. Else panic binary op not implemented. Oh, it's supposed to call this. Oh no, it does panic. Oh, excellent. Okay. Do we really want to panic though? Eval binary. Oh man, do these are supposed to panic? That's crazy. Doesn't that mean, like, if the user... No, I mean, there's no way this is how this works, right? Let me think about this a second. I guess these are called internally, and somewhere else we're going to have to guard against this kind of panic. So this is also why these ops should just be these ops should be enums. But we're gonna hold off on that for now. Okay, and then we're gonna call fun dot. We're gonna hold off on that for now. Eval binary. How do we do it up here? Self left right. Wait, what? Consider using option expect. Wait, how did this work up here? Oh, because I forgot to say sum. Why does unary take? Oh yeah, okay, same here. This doesn't need to move it. Just stir, and then we can borrow here, and then we can take off this. Great. I can take off this, I think. Borrow this. Take this off. This off. Multiple fields, great. Okay, exec, no, context is where we are. Okay, oh, we're almost at the end here. Binary, define checks the function, installs it, also performs some error checking, and adds the function to the sequencing information used by the sequence. Okay, pub fn define. Takes a self. It's going to take, I'm pretty sure it's going to take a ref view of self. And it's going to take a function. Doesn't return anything. What is novar? Ah, okay. So this is a method on context. Wait, what? Where did this come from? Oh, it's just farther down in the file. That's pretty funny. Okay. Novar. guarantees that there is no global variable with that name, preventing it off from being defined with the same name as a variable, which could cause problems. A variable with value 0 is considered to be okay, so one can clear a variable before defining a symbol. Clear variable is removed from the global symbol table. No var also prevents defining built-in variables as offs. Okay. If name equals this, or name, oh my goodness. Panic, can't define op with name. Why is this unneeded? Oh, because this is the end of the function, but it's about to not be. If I, okay, sim, oh, okay, hold on. Alright, hold on. Hold on. What is this? This is an option. Option, what is this? Option ref value. Oof. See, clause name. Okay, sim dot. So we're casting it as an integer? I'm pretty sure this is a cast. Okay, on type cast go. Yeah, I'm pretty sure that's what's going on. Start 2. Where's error 2 at? Is not as easy. Can type assertion. Yeah. Yeah. Handle error. SOKV dot string. Yeah. Sweet. Okay. Well, if we can cast it as an integer, but sim is a value. Ah, I see. Okay, hold on. If let some sim is this, then I'm going to try to cast it as an integer. But we don't even have integers yet. Where's value? Value. Where's my enum? Value. Call it an int. I32. Generate. We only need it for this so far. Generate is. Okay. So we don't have to check okay because we already did the if let sum. So I can now check if sim.isInt and oh, alright, I see. If let int I equals sim. Can I do that? Yeah, I don't think so. Let expressions in this position are unstable. If I is 0, this is kind of goofy, right? A variable with value 0 is considered to be okay, so you can clear a variable before defining a symbol. So if you want to define a symbol with the same name as a variable you had before, you have to set the variable to 0 and then define it. Weird. Yeah, I mean, you even tell the user that. That's weird. If I is 0, then we can take self. So now this has to be mute as well. Self.globals dot remove sim. No, not sim. We need to remove name. Whoa. Value ends. And now we take mute self. Else return. Well, hold on. Yeah, else return. And if we get down here, we panic and we say cannot define op name. Oops, not this one. Quoted string for rest. Is there one and I just don't know it? Oh, probably I should use the debug formatting, right? Yeah, that makes sense to me. Where are we right now? Over here? We're in Novar, right? Novar. Well, I'll just do it like this. Cannot define op name. It is a variable. Whoops. Is a variable. One equals 0 to clear. Oops. Great. So inside of define, the first thing we do is call novar. Self.novar. Fun.name. Oh, right. We can make this pub, I guess. Well, or we can make a getter method. Why does it do that? So this basically asserts that there's no variable. Okay. Now, if fun.is, now this is supposed to be pub, is binary, self dot binary fn dot insert name fun. What is going on? Okay, makes sense to me. Else self dot unary fn dot insert Okay. Then we have to update the sequence. Okay, define. Installs it, performs some error checking, and adds the function to the sequencing information used by the save method. Great. Update the sequence of definitions. First, if it's last, a very common case, there's nothing to do. If self.defs.length is 0, let last equal self.defs.last. Okay. We can unwrap because we just checked. Oh, yeah, right. It's not empty. Then we just grab last. Let last. Okay. If last dot name equals fun.name and last is binary equals fun.is binary. We just return because it's already installed, I guess. Oh geez. Okay, I guess we should do this. Let fib equals fun.is binary. We can just grab that first. I was gonna say it's moved again. Yeah. Okay. And now I can use actual name here. Ugh. I'm just gonna have to clone it. Just forget all of this. So we will use fib. Okay. So we move the name away. Okay. What is the problem now? We need, okay, there we go. Okay, we just need another copy of the name, Jesus. All right, if no name, we'll return, otherwise, we'll check if it's already defined. Is it already defined? For I def.name equals name, and def.isBinary equals fib. Yes, drop it. Self.defs dot remove I. Ooh. Yeah. Okay. Let mute pops. Oh no, we should just, this is just a map, right? Okay. Self.defs.iter.filter. Yeah, filter def dot, yeah, okay, I already typed this. Keyword def.name, yeah, and that's it. That's just how we filter it right there. Collect into self.defs. Why can't I, what's wrong here? Oh yeah. Yeah, this is gonna be the same thing. Let defs equal this. Defs dot collect into self.defs. What? Collect into. Oh, that's fine. Yeah, I don't mind that. New reference. Okay, copy op def. What? Yeah. Derive clone. And this, it has to be copy? Why does it have to be copy? Lib feature, what's it called? Iter collect into. Okay, no, we're still upset, probably because these are like, yeah, it's also barred as immutable. Okay, we're just gonna have to collect it then. And we're just gonna say self.defs equals defs. Can you, okay, we're gonna have to like, can you like into iter? Retain, okay. Self.defs dot retain. Okay, now I think I have this backwards actually. Delete this, delete all of this. I need to go back and look at the code. We're probably retaining like the opposite of what we want. Okay. If this is the case, we're supposed to drop it. It's already defined, so I think we drop the old value, right? If it's defined, drop the old one, break the loop. Oh, I shouldn't have done this. Okay. I'm just gonna go back to the loop. Well, this is why I need to put undo tree back in. Yeah, okay. So we're just gonna... I guess what we want is this, actually. Let I equal self.defs.iter.find returns the index, right? That's what we're hoping for. X equals 2. Not find, index. Takes a closure, it applies this closure to each element. If any of them return true, then find returns the element. How do I locate it? Find. Rest find index. Is it just called index? Find the index of an element. Position. God, I always forget that. Dot position. If let sum I equals I, self.defs.remove I. Yeah, because the idea here, right, is we're looking through the definitions, finding if any of the definitions already have this defined. If we do find it, so position is sum, then we drop it. Okay. Drop it if so. Drop the existing value if so. And once we've done that, then we just say self.defs.push op def. What? Push op def new name. Good. What's the problem here? Borrow later. Oh, geez. Okay, great. It's now the most recent definition. We handled novar and no op, the dual of novar. Okay. So almost done. I think when I finish this file, we're probably gonna call it a day. I guess we've been going for 4 hours already, so. Okay, fn, no op, ref mute self, probably. And a name, doesn't return anything. Okay. If name equals pi, or name equals e, panic, can't reassign name, self dot unary fn dot contains key. Wow, I knew exactly what I wanted. Name. Oh, is this not contains key? Binary fn dot contains key. Return. Else, we're gonna panic. Cannot define variable name. It is an op. Yeah, this should be not. If not, and I would kind of actually rather invert this, right? Like, if it is unary or it is an existing binary, then we panic, right? Yeah, because that's what we're doing. If it's not unary and it's not, see, it makes sense in Go to do it this way because you've got the like this returns nil, but I'm checking if it contains key. I don't have to do like get is sum. I can just say contains key. Nice. So where do we actually call no op? Nope. Nothing. Well, anyway, we'll leave it for now. Pub fn declare. Takes the roughing itself, the name, which is a stir. Doesn't do anything, it just says self.variables.push name. Great. Declare makes the name a variable. Fn forget all takes ref itself. Self.variables dot clear. Clears vector, remove the values. And then fn is variable. Self op. Okay, we'll just do this for now. Okay, so we finished context. Finish context.go. Let's say there might be another context, so we'll say exec/context.go. Okay, that's great. So I think that's probably going to be it for me today. Like I said, we went over 4 hours. We got some people stopping by, so 35 views. That was great. So maybe, I think I have off this week from work for Thanksgiving, so probably I'll be working on this some more this week. And I'll see you guys then. Thanks for tuning in. See ya.